Uh, Good afternoon, learners, and welcome to Dr. Diyapatil Vidyapit Center for Online Learning. I'm your faculty, Professor Anand, for this course that is OMB AIML 303 and OMBBA 305, that is Performing Analytics with Python. Learners, in this session, we are going to learn about unit number 5, that is data pre-processing and visualization. So before I could proceed further in the session, please confirm in the chat box that I'm audible and my screen is visible to all of you. Please confirm in the chat box. I'm audible and my screen is visible to all of you. Am I audible? Yes, you are audible and screen is visible. Thank you, Juvenso. So let's start with this session. That is unit number 5, data pre-processing and visualization. So in this session, I'm going to cover about EDA, that is exploratory data analysis. And I'm going to cover about how to import the data and how to perform, how to extract the basic insights from data set and how to visualize your data by using the visualization tools like Seaborn and Matplotlib. So after studying this unit, you will be able to generate meaningful insights. You will be able to extract meaningful insights from the data, which will help you in decision-making process. And this will make you to understand how to perform EDA, that is a data exploratory analysis, and how to use the basic visualization tools like the bar charts, line graphs, and scatter plots. So this is the agenda for this session. So when I say EDA means what? EDA is exploratory data analysis. So first here I'm giving the theoretical explanation about the topic, and after that I'm going to demonstrate EDA, how to perform EDA practically by using the Google Colab and Python. So basically, when I say EDA is a critical phase in the entire data analytics process that involves examination, inspection of the data, visualization of the data, finding out the characteristics of the data, uncovering the patterns, finding out the relationship in the data, finding out the anomalies, and gain the valuable insights. So if I put all these functions together, then I can call it together as a exploratory data analysis, where I am finding out the characteristics of my data set. I'm trying to understand the relationship between the data points in my data set. I'm trying to find out whether there are any anomalies present in that data set, and I will get the valuable insights from my data set once I perform exploratory data analysis. So that's why exploratory data analysis is a critical phase in the entire data analysis process. And to perform the EDA, we use the data analysis techniques to summarize the main characteristics of a data that we have seen by calling the describe function on the data set. We will be able to describe the data like mean, what is the mean, mode, median, quartile 1, quartile 2, and quartile 3. So all these characteristics of the data can be summarized with the help of that describe function that I have shown in the some of last my examples. Again, here we are going to use that function. So here, usually by using the graphical representation and basic statistical summaries, we are getting the main characteristics of a data set. by using some graphical representation like the histograms, charts, like graphs. We are trying to summarize the data set, and this can be done with the help of some statistical functions and by using the graphs. I'm describing the characteristics of my data. So the EDA provides an initial understanding of the data. Understanding of the data is very, very important. That will give you the shape, or that will give you an idea in your entire data analysis process, how you should approach your data analysis, what models that you should select, and how you should proceed further in the data analysis. That will be depends on finding out the characteristics of data. So that's why finding out the main characteristics of data set is very, very important, and that we can do with the help of some graphical representation and basic statistical methods that will provide you the understanding of the data, and that allows the data analyst and scientist to familiarize themselves with the data structure, with the content, with the context. So that's why EDA is very, very important phase in entire data analysis. And EDA involves techniques for cleaning the data, transforming the data, and visualizing the data, which will facilitate the identification of interesting and informative aspects of the data set. So that's why EDA is very, very important. And if I am using Python, Python provides you many functions. Python provides a function for data cleaning, for finding out the outlier detection, that is anomaly detection, and it also provides the function for variable transformation. That again we have seen in some of my last examples. So now, straight away, without wasting time here, we will move on to the practical example of this EDA. So let me share the screen and tell me that whether my screen is visible to all of you or not in the chat box. So here I'm sharing the screen of my Google Colab, that is unit5.ipynb. So I hope it is visible. Solomon, yes, it is visible. Thank you, Solomon, for confirming. So now, as you can see that here, the first step is to mount your Google Drive in Google Colab page. Why I need to mount? Because here I'm executing the example online, not on a local machine. So when you're executing the example online, so for that we need to have a data set. So, and that data set is present in my Google Drive. So I need to mount the Google Drive so that I can use the data set which is stored in my Google Drive. So first thing first, that we need to mount the Google Drive so that you can refer the data set that you have stored in your Google Drive. So from google.colab, import drive. After that, drive.mount, specify the URL, absolute URL of the drive, like say quotation mark /content/drive. So this will mount my Google Drive to this Google page. Once the drive is mounted, now I can load that data set into this Google.colab page, and I can perform data analysis. I can perform the exploratory data analysis. So when I try to connect, it's saying that connect to the Google Drive. Yeah. It is asking that which email that you want to attach the Google Drive. Select the email ID, then click on the allow button so that Google Drive is successfully mounted in this Colab page. So now it is successfully mounted. As you can see that mounted at /content/drive. After that, the first thing first that we need to import the libraries, that is pandas and numpy as PD and NP respectively. After that, by using the pd.read_csv function, we have to load the data set into this Google page. Okay, so data is equal to, I'm creating a data frame here, is equal to PD is the object of pandas and read_cv is the function which is defined in pandas, so that I can read the content of my data set into this unit5.ipynb page, that is Google page. So here I have to give the complete address of my data set, starting with content/drive/my_drive/company-sales.cv. So this is the data set that I am using here for this example. Company-sales.csv. So once this command will get executed, the data set will be stored into the variable called as data. So now this data, I can use it as an object that represent my data set. So after that, once it has been successfully loaded, then we need to print the information about the basic information about the data frame. Like, say for example, if I say data.info, so what I will get here, okay, we will do one by one. So I will just comment this so that you will be able to differentiate the output of each of these. So now first, I want to display the information, the basic information about the data frame, that is company-sales.csv. So now we can see when I call upon the function that is info on the data set, that is data.info, then I will get the information like what are the column names and what is the data type. So for example, the column name is face cream and its data type is 64. So you can see that all the column names of my data set. So this is a data set about face cream, face wash, toothpaste, bathing soap, shampoo, moisturizer, their total units, that is total units sold and total profit that I have gained. So this is a data set about a company dash sales, showing the details of the products which are being sold in the unit of number of units and the profit earned. So when I call data.info, you will get the information like the column names and their data type. So as you can see that here, data type, that is int64, that is integer data type. And you can also see that total there are 9 columns. So all these things can be displayed with the help of data.info function. So after that, if I want to describe the data, or I will comment this. So if I want to find out the statistical information about the data, then you need to call data.describe. So when I execute this function, that is data.describe on my data set, now we can see the information about the mean, the mean mode, and the mean, the standard deviation, the minimum, and the quartile 1, quartile 2, and quartile 3, and maximum with regard to all the products in my data set. So here you can find out the statistical summary of your data set. So when I call the data.describe, you will get the statistical summary of your data, isn't it? So after that, if I want to find out the missing values, the second thing is that I need to find out the missing values. See that your data set should not have missing values. It should not have empty rows. It should not have duplicate rows. It should not have anomalies. Then only you can perform the data analysis. You can build a model, and that model can predict the future outcome. If your data is cleaned, if your data is accurate, then only whatever inferences, whatever extracts, whatever insights that your model is going to give you, it depends on the accuracy and consistency of the data. So that's why we need to perform these primary operation or primary tasks on the data set, like first getting the basic information about the data set, getting the statistical summary of your data set, then finding out if there are any missing values, if there are any duplicate values. Then if you find the missing values, if you find the missing rows, you need to remove those missing rows. If you find the duplicate rows, you need to remove that duplicate row as well. So the second thing is that you need to find out the missing values. How we can find out the missing values? By using the function called as data.isNull.sum. Means what? Here I'm trying to find out how many missing rows are there in my data set. So here, with the help of data.isNull.sum, I can find out the number of rows which does not have a data. So let's execute this code. So now you can see that total face cream doesn't have any missing values. Face wash column doesn't have any missing values. Toothpaste, bathing soap, shampoo, moisturizer, they don't have any missing values. So here I'm trying to find out the sum. How many missing values are there in face value, in face cream, in face wash, in toothpaste, in bathing soap product. So here I'm trying to find out the sum of the missing values for each of these columns. So 0 means what? There is no missing value of any of the columns. As you can see the result, that is 0, 0, 0, 0, isn't it? So there is no missing value. Now, we will try to find out the duplicate values. So how we can find out that if I found the duplicate rows, then I need to drop. So automatically the missing the duplicate rows will be dropped. So how we can do that? By calling the function that is data.drop_duplicates. If there are any duplicate rows, duplicate values, they are automatically deleted with the help of data.drop_duplicate function. So I will execute it. No. So here, there won't be any duplicate values. If there are, then they are automatically deleted. So after that, so now what we have performed, we have described the data, we have displayed its initial information, then we have found out any missing values, and then we have removed any duplicate values. So after that, I need to display the initial 5 rows, 1, 2, 3, 4, 5 rows. That is, I want to display the first 5 rows. So the function is data.head. So this will display the first 5 rows of my data. And in the same way, if you want to display the last 5 rows, then you have to call the function called as data.tell. So data.tell will display the last 5 rows, and the data.head function will display the first 5 records of your data set. So after that, I want to display the data on the histogram. So here I need to import the matplotlib.pyplot as PLT. So now I can use the PLT and I can draw the histogram. Again, I need to import the Seaborn as SNS. So with the help of this two libraries, that is Matplotlib and Seaborn, here I am plotting the values on a histogram. So data is my data set. What column that I want to display here? That is face cream. Dot plot is the function. What kind of plotting I want here? I want histogram. Beans, I want 20 beans. Number of beans is equal to 20. After that, with the help of plt.title, I'm giving a title to my histogram, and with the help of plt.show, I am actually displaying the result on my screen. So let's execute one more time. Yeah. So what I will do here, I will remove this SNS Seaborn. Actually, Seaborn is not required. Yeah. So here I have used only the matplotlib, that is PLT, to draw the histogram. So you can see that the frequency is being shown on the Y bar, and on the X bar you can see its cells. So this is, I have just plotted the face cream. You can give all any other. So for example, if I can change from face cream to say face wash. So here I will draw face wash instead of face cream. I am changing it. So now the details of face wash will be plotted on the histogram. So this is how we can plot the data of a particular column on the histogram, so that we can find out the hidden patterns, or we can extract some insights from the data visualization. So here I have visualized the data by using the histogram. Again, for toothpaste, again, I have done the same thing, that I have plotted the data of my toothpaste on histogram as well. As you can see, the same syntax, only I have changed the toothpaste here. So this is how we can plot the data by using the histogram. Now, I want to draw the correlation matrix. So for that, I am drawing I am creating the object of that correlation matrix with the help of data.corr, so that I can get the object of the correlation matrix. So now with the help of the SNS, that is SNS that you have seen, SNS is I have imported the Seaborn as SNS. So now with the help of SNS.heatmap, I am drawing the correlation matrix with the title as correlation matrix, and with the help of plt.show, I am displaying the correlation matrix for my data set. So this is how I can represent the correlation matrix for my entire data set. So this is about correlation matrix. Now, I want to show the monthly sales visualization. I want to visualize the monthly sales. So for that, here I'm using the matplotlib's PLT dot plot the month number, comma, the total units, The title for my graph is monthly sales of total units. For X label, the month number, sorry, and for Y label, total units. So this is total units, Y label, and X label, X bar will contain the month number. So now, with the help of Matplotlib, I am visualizing the data, monthly sales by using the Matplotlib's object. So now, as you can see here, monthly sales of total units. So here I have displayed the monthly sales of total units, that is month number and total units. So in every month, what is the total units sold? Okay. So total monthly sales of all the units. Now, if I have to see all the products monthly sales, so this is only for month and total sale. Now I want to see the product wise sales comparison. So again, here I have drawn the product wise sales comparison. As you can see here, I have defined the loop for product in products. So we can see that in products, I have data.column, that is 1 to 7. I have stored all the columns into products. After that, plt.figure, a fig size is equal to 14,8. That will be my figure size. That will be the dimensions. Then I am defining a loop that is for product in products, plt.plot data as month number, comma, data as product. So every product will be replaced here, label and maker. So now by using the title, I'm giving the title, by using the title function, I'm defining the title for my graph, that is product wise sales comparison. X label will contain the month and Y label will contain the total sales for each of the product. And with the help of the legend function, I am showing which label or which product, which column is having which color, so that you can easily find out its relative values. And by using the show function, I am displaying the graph on my screen. So as you can see here, all the products, their total sale as per the month number. So you can compare the total sales product wise. So this is how we can perform EDA. So in this particular session, we have understood about how we can able to import the data set by using read_CSV. That how we can able to load it by using pd.read_CSV. After that, how to display the information with the help of data.info function, how to display the statistical information with the help of data.describe, how to find out the null values, that is missing values, with the help of data.isNull, and how to remove the duplicate values from the data set with the help of data.drop_duplicates. And after that, how to display the first 5 lines, how to display the last 5 lines, then how to plot the data by using the histogram individually, that is individual product wise. Then we have seen how to create a correlation matrix for the data set, then how to display the month-wise sales of total units, then we have seen how to display the product-wise sales comparison. So this is about unit number 5, that is uh, data pre-processing. Okay, let me come to the PPT. Give me a moment. Yeah. So this is unit number 5, that is data pre-processing and visualization. So basically here I have covered about yeah. So here I have covered about the main components of this unit, that is what is exploratory data analysis, how to import the data set, and how to get the basic insights from data set, and how to visualize your data set using the tools like Seaborn and Matplotlib. So this is about unit number 5. Now we'll start with unit number 6. If you have any questions regarding this unit number 5, you can paste your questions in the chat box. Now let's start with unit number 6. I hope the content that I have explained here that you have completely understood. If you don't have any questions. So now we are moving to the unit number 6, that is mathematical and scientific applications for data analysis. And this unit is all about the NumPy and SciPy packages and the universal functions which are present in NumPy and SciPy package. So in this unit, we are going to learn about the universal functions of NumPy and SciPy package. So basically, what is NumPy, guys? NumPy stands for numerical Python and SciPy stands for scientific Python. So NumPy will give you the functions that you can process your data, that you can interact with arrays, isn't it? And SciPy will give you the mathematical functions. So NumPy will give you to process your data or to create the multi-dimensional arrays or n-dimensional arrays. That is the use of NumPy, which allows you to process numerical data analysis. That is numerical Python, that is NumPy. So as I said that NumPy, okay, I will share the screen here. Yeah. I hope the screen is visible. That is NumPy and SciPy package. So basically, what is NumPy? NumPy is a numerical Python. It's a fundamental package for numerical computations in Python. So in every Python code, yeah, thank you. So in every Python code, you more often than not, you will witness NumPy and SciPy. So NumPy is a fundamental package which is used for numerical calculation, numerical computations, which provides support for the large and multi-dimensional arrays and matrices. So basically, using NumPys, we can create multi-dimensional arrays or n-dimensional arrays and matrices, along with a wide range of mathematical functions to operate on these arrays. So the NumPy not only provides the support for the large or multi-dimensional arrays and matrices, but it will also give you a wide range of functions that you can use, that you can operate on these arrays. And when you talk about this SciPy library is built on the top of NumPy. So SciPy is the extension of NumPy, which provides the additional functionality that it contains the more scientific methods or scientific functions. So it additionally provides the functionality for optimization, signal processing, statistical functions, and more. So basically, the SciPy package is used for more of performing mathematical operations like optimization, signal processing, or statistical analysis, or it will provide the statistical functions and more. So now let's directly go to the example of NumPy and SciPy. I hope you understood what is NumPy and what is SciPy. These are the packages. These are the packages, or we can say libraries, or we can say modules of Python. NumPy contains the functions that you can, using which you can create multi-dimensional arrays and matrices. And again, it gives you the functions to operate on these multi-dimensional arrays. We have three types of arrays. One is single dimensional, having single row and single column. Second is two-dimensional arrays, having two rows, more than one column, that is called as two-dimensional. Then we have multi-dimensional, that is more than two-dimensional, that is called as multi-dimensional arrays. So here, the NumPy will allow you to create n-dimensional, that means multi-dimensional, and it provides you the functions that you can play with, that you can use with, that you can operate for performing computations. And whereas the SciPy, that is scientific Python, contains more of statistical methods for performing statistical computations like signal processing, integration, optimization, and many more. So it contains the functions for scientific computation and engineering purpose, or engineering, to perform the engineering activities. The SciPy will give you the functions. And SciPy is built on NumPy. So we can say that SciPy is the extension to the NumPy library. So now we'll go to the practical part of this NumPy and SciPy, and I will share the screen of Google Colab, and I hope that the screen is visible to all of you guys. That is unit number 6.ipynb Google page is visible onto your page, or onto your screen rather. So first thing first, we need to import the NumPy so that I can use all the functions of NumPy. So here I have imported NumPy, and after that, I'm creating the array with the help of the function that is array. So np.array function, as you can see here, and to this array function, I'm providing a list containing three values, that is 1, 2, and 3. So here, from the list, I'm creating a single dimensional array. So with the help of np.array function, as you can see that this is a function, and to this function, I'm providing the argument in the form of a list that is having values 1, 2, 5. So this will create a one-dimensional array. One dimension means what? Single row, and single column. So after that, I am displaying the values of my ARR. So let's display them one by one so that we will be able to understand how one-dimensional array will be displayed. So now you can witness that when I create one-dimensional array, how that array is going to be displayed. As you can see, one-dimensional array that is in the form of 1, 2, that is 1, 2, and 5. As you can see that it contains a single row and a single column. Single row, it contains a single row, that's it. So wherever you see a single row, it is having a one-dimensional array. So here it has created a one-dimensional array by using, when I specify the values as np.array, and values are 1, 2, 5. So this is the output of this print function. Now let's create, I will comment that. Now I'm creating a two-dimensional array. I'm creating a matrices. I'm creating a matrices. How to create? Again, simply, I am providing here as two, we can say two lists, that is 1, 2, 3, 4, 5, 6. So here I'm providing two lists. This is one list and this is second list. So now it will create a matrix, that is a table having multiple rows and multiple columns. So with the help of np.array, but to this array, I have provided two lists. So now when I execute this command, a matrix will be created with having two dimensionals. So let's print it. So as you can see here, okay, print, I need to uncomment the print. So now we can see the result of this print function, that is a two-dimensional array. In the first row, having three columns, 1, 2, 3. In the second row, having three columns, that is 4, 5, and 6. So this is how we can create single dimensional array, and we can create matrices like a multi-dimensional array with the help of the NumPy function, that is array. Now next, the universal functions which are present in NumPy, that we call as ufuncs, that is universal functions present in NumPy library. So the NumPy library is a huge library which contains the functions for performing arithmetic operations, for performing the mathematical functions. So and the uniqueness, or we can say the feature of this NumPy universal function is that the operation is performed on all the elements on your multi-dimensional array, or on your single dimensional or multi-dimensional array, whatever parameter that you pass to that function will perform the action on each and every element of that array. That is the specialty of these universal functions. So here I don't need to define a loop in order to repeat. So for example, I have values as 1, 2, 3, 4. Now I want to perform the addition of all these elements. So what I will do, I will define a loop and I will iterate all the values in the loop one by one, and I will make a sum. But instead of writing that loop, I can perform the same operation. I can have the same output by using the function, that is using the NumPy universal function called as add, or we can say by sum. So when I say np.sum, so what it will do, it will make a sum of all the elements and it will give me the result as a single value. So writing a single line will give me the sum of all the elements present in my array. Otherwise, I would have to define a loop. So I repeat that the feature of these NumPy universal function is that they perform the action on all the elements of your array. So ufuncs are the functions that operates element wise on ND array. ND array is the object which is present in NumPy, and that using that object we are creating the multi-dimensional array. So here let's first see the arithmetic functions on the array. So here I want to perform the addition. I want to add number 5 on each of my elements. So what are my elements? My elements are, that is 1, 2, 5. As you can see that I'm using ARR, isn't it? I'm using ARR array. So ARR array is a single dimensional array. So on this ARR array, I'm performing all the ufuncs, that is NumPy universal functions, like add, like the subtract, like multiply, like the divide, like the sin, and etc. So here I'm performing all the NumPy universal functions on my array that is defined as ARR, having values as 1, 2, 5. So guys, remember this value. Okay. So after that here, as you can see, I want to add the number 5 on all these elements. 1 plus 5, 2 plus 5, 5 plus 5. I want to add 5 in all these elements. So when I add 5 into the first element, it becomes 6. When I add 5 into the second element, it becomes 7. And when I add 5 to the third element, it becomes 10. So the output would be 6, 7, and 10. So now let's see whether I will get the same output or not. So one more time here, I will execute the command or execute the cell. Now you can see in the output that 5 is added in every element of the array. Now you can see that the value of 1 becomes 6, the value of 2 becomes 7, and the value of 5 becomes 10. So as you can see that by writing a single statement, I'm adding number 5 or value 5 in each of the elements. This is because of the universal functions present in NumPy library. Otherwise, I would have to define a loop, and after that, I need to add the number 5 in each of the element of the array. And for that, I need to write 4 to 5 lines. So instead of that, I can perform the same output. I can have the same output by writing a single statement. So this is for adding a value in each element of the array. Now, if I have to subtract, if I want to perform a subtraction, I want to subtract the value 1 from each of the element of my array. So what are the elements? The elements is 1, 2, 5. Now, when I say np.subtract, so this is np.add. This is the data set, we can say array, and this is the value that you want to add. So it accepts 2 parameters. When I subtract, here I'm providing the np.subtract is the function name. Array is ARR, 1. So what it means that? It means that I want to subtract 1 from each of these values, that is 1, -1, 2, -1, and 5, -1. So what would be the result of this statement, that is np.subtract? I should get the value as 0, 1, 4. So let's execute them and watch out for the output. Can I get it? Yes, I have got the result. 1 -1, 0, 2 -1, 1, and 5 -1, 4. So this is the output of np.subtract. In the same way, I can perform the multiplication and other arithmetic operations as well. Say, for example, when I say np dot multiply array, that is ARR, comma 2. So what I mean to say here is that every element of my array, that is 1 comma 2 comma 5, will be divided, will be multiplied by number 2. So 1 multiplied by 2, 2 multiplied by 2, and 5 multiplied by 2. So what would be the result? The result should be 1 into 2, 2, 2 into 2, 4, and 5 into 2, that is 10. Let's find out whether I'm getting the same output or not. Yes, I'm getting it, same output. So this is the result of multiplication. Again, if you want to perform the division, again, you need to call the np dot divide function. So if I divide, then what I will get here? I will get every number of my array element is divided by the number 2. And as you can see, the result is 0.5, 1, and 2.5. So every number is divided by 2. Then if you want to perform the square root, or if you want to find out the square root, or before that, so these are all arithmetic functions, isn't it? All these are arithmetic functions, that is add, subtract, multiply, and divide. Now let's see some mathematical functions which are available in NumPy library, like sin, like mean, like the max, or like the mean. So here I'm performing the mathematical functions on element wise. That is, I want to find the sin of the array. So np.sin will give me the sign of my array elements. So let's execute this. So now I'm getting the result that every element sign is this value. So in this way, we can find out the sign of all the elements of my array. So that is SIN, the function name is. Then if you want to find out the square root of your array elements, then the function name is np.sqrt, and provide the object of the array, that is ARR. And when you execute this, you will get the square root of the values of your array, that is square root, that is like this. So again, if I change the value of my array, say for example, I am changing from 5 to 25. So now my values of array are 1, 2, 25. So now I will execute this. And in that case, I will get the square root as, for 25, I am getting the square root as, say, 5. Isn't it? So now, so this is about the square root function. So again, here I will change it from 25 to 5 so that we are consistent with the output. So this is about SQRT, that will give you the square root of all the elements of your array. Then if you want to find out the sum of all the elements of your array, then the function name is np.sum, and specify the name of the array object, that is ARR. So now this will give you the sum of all elements, that is 2, that is 1 plus 2 plus 5. So the sum is 8. If you want to find out the minimum number, that is mean of the array, so for that we can call the function, that is np.mean, MEAN, and provide the name of the array, that is ARR. And when I execute that, I will get the mean of my array element, that is 2.6666 and 6. If you want to find out the maximum number and minimum number, again, this is possible with the help of np.min will give you the minimum number, and np.max will give you the maximum number. So the minimum number of my array is 1, and the maximum number of my array is 5. So one more time, I will execute it so that you will be sure of the output that I am talking about. So minimum number is 1 and maximum is 5. So here we have witnessed the NumPy universal functions. And the speciality of NumPy universal function is that they perform the operation element wise. We don't need to specify the loop. So that is the advantage of using the NumPy universal functions. Now let's see some functions of the SciPy. Like I said that the SciPy is used for scientific applications, scientific and engineering applications. They provide advanced mathematical functions. So first thing first, we need to import the SciPy, and SciPy has been built on top of NumPy. So we can say that SciPy is the extension of NumPy. Also, when you import the SciPy, we don't need to import NumPy, because ultimately all the libraries, all the functions are automatically available when you import SciPy, since SciPy is built on NumPy. So that is the logic. We don't need to import NumPy here. So here we are using the integrate module from the SciPy and defining function, that is integrate. This is a quadratic function, that is quadratic underscore function is defined, and the integrate dot quad is used for definite integration of the quadratic function over the interval 0, 1, and the result and the estimated errors are printed. So here we have defined the quadratic underscore function. So this is a user defined function, and here I am providing a variable. So here I want to find out the estimated error. So here result comma error is equal to integrate dot quad. So this is the function that I'm using from the SciPy, that is integrate dot quad, quadratic comma function. So here I'm calling the function. So the result of this function will be provided here, and with the interval of 0, 1, I am displaying the result of the quadratic definite integration, that is the result and the estimated error. So now let's execute this. Yeah, so we'll get the result of the definite integration, and you will get the estimated error in the result, again this value. So this is about the function that is integrate dot quad, which is used for definite integration of the quadratic function over the interval 0, 1. Now one more example that here I'm giving, that is optimization using the minimize in SciPy. So here again from SciPy dot optimize, I'm importing the minimize library. Here I'm defining the function that is quadratic loss underscore loss, and here I'm calling that quadratic underscore loss to the minimize function with the value of 0. So use the minimize to find the minimum of the quadratic loss function and storing the result into the result variable. And after that, I'm displaying the minimum value is found at the result dot x. So the minimize function from the SciPy dot optimize module is imported here, and a quadratic loss function, that is quadratic underscore loss, is defined, and the minimize function is used to find the minimum of the quadratic loss function starting from the initial guess, that is 0, and the result and the containing minimum loss is printed. So this is about the two functions that here I have demonstrated here. So this is about the universal functions, about NumPy and SciPy. So guys, today I have covered the unit number 5 and unit number 6 in this session. So if you have any questions, please go ahead, ask in the chat box, or else before I conclude this session, here I have given the link for your feedback. And I request all the learners to fill this Google form and give your feedback. So I hope that whatever content that I have covered here, that is unit number 5 and unit number 6, that you have fully understood. So basically here in this session, I have covered about EDA and I have covered about the NumPy and SciPy universal functions. So with this, it seems that there is no questions in this session. I would like to conclude the session here. Thank you very much for joining this session. See you in the next class. Until then, a very good day for you. Thank you very much for joining this session.